Okay. Hi, class. My name is Barbara McPherson, and today we're going to be talking about abnormal pacemaker activities. Okay. Um, and conduction systems of the heart. Okay. But before we get into talking about abnormal pacemaker activity, we need to discuss some normal pacemaker activities and how this functions. So the heart has a unique ability to have its own conduction system. So what that means is that the heart can produce an action potential without any assistance from the nervous system, um, such as what you would have to have with neurons and muscles and stuff like that. The heart can do it all by itself. It has its own unique system to do that. This is due to what is called autorhythmic cells in the heart. Now, the conduction system of the heart is controlled by several structures in the heart. These structures are called the sinoatrial valve or the SA node, or I'm sorry, sinoatrial node or SA node, which is right here in the heart. The atrioventricular node or AV node, which is right here. And then it's going to go down to what is called the bundle of His, which is right here, this little area right here coming off of the AV node. And then the next structures, these are called bundle branches. And then we go into these little things here are called Purkinje fibers or Purkinje fibers. Okay, so each of these each of the cells in your heart has a different rate of depolarization. So therefore you have different rates of action potentials. So the SA node produces it's between 70 to 80 action potentials per minute. The AV node produces between 40 to 60 action potentials per minute. The bundle of His and the Purkinje fibers produce between 20 to 40 action potentials per minute, considerably slower than the other two structures. So the fastest one, going back up here again to the SA node, the fastest one, node, that's the one that's going to lead the conduction system. That's one that's going to jumpstart it. It's going to kick it off. And as you can see, this node is up here in the upper right part of the heart, right up here by the superior vena cava is where it's located at. So um, what's going to happen is that SA node is going to set the pace for the heart because it can produce an action potential faster than the other structures. So what the SA node is responsible for is generating the electrical signal that depolarizes the cardiac muscle. So that depolarization causes the contractions of the atrium, of the right and left atria. And then that signal is going to come all the way from here. It's going to come down. This is going to contract, and then the signal is going to go into your AV node. Once it gets to the AV node, the signal will be delayed for just a little bit, not long, just a few seconds. And then it will pass on from the AV node into the bundle of His. And once it gets from into the bundle of His, um, it'll go down the bundle of His and continue traveling through the the ventricular myocardium, I'm sorry, until it gets to these little end branches called the Purkinje fibers. And then it will fire and the heart will beat. Okay, the next one then, since we've talked about the normal conduction of the heart, now we can talk about the abnormal conduction of the heart. What would happen if one of these structures, one of these nodes in the heart, didn't function properly? So let's say the SA node right here. I put a little X through this so you can see that the SA node is blocked for some reason due to probably some kind of disease or something. So if the SA node is blocked, Then the AV node is going to have to come in and act as the pacemaker and take over the role of setting the pace for the heart rate. Well, if you'll remember back just a few minutes ago, the AV node is slower than the SA node. The AV node will only produce between 40 to 60 action potentials per minute. So it's not going to go as fast. It's going to conduct slower. Still going to work, but it's not going to be as fast as your SA node. Okay, so then, say we have an issue with the AV node. Okay, well, your SA node is still firing up here, but this is blocked for some reason due to some kind of disease or failure of something. Since this is blocked, then you can't get a signal all the way down to the rest of your heart. So what's going to happen then is the bundle of His and the Purkinje fibers are going to have to pick up and do the job of what the AV node would do. So now, again, if you'll remember back, this is not going to go very fast. The bundle of His and the Purkinje fibers will only do 20 to 40 action potentials per minute. It's considerably slower than both the AV and the SA node. Okay, so but up here on the atriums, the SA node is still working. So what's going to happen is this is going to fire an action potential at 70, or between the 70 80 beats per minute. So the atriums are going to beat faster, but what's going to happen is the ventricles and the rest of the heart muscle, the rest of the heart down here is going to go slower. It's only going to go to 30 to 40 beats per minute. This is going to be, you're going to need medical attention quickly when this happens. You're going to need probably a pacemaker installed if that particular thing happens. But I'll show you an analogy of how this works, like if it was a train. Okay, so you say you have these cars on this train. Okay, and each one of these these are autorhythmic cells, these are contractile working cells. Okay, so this is a normal pacemaking activity. The SA node is leading the pack with 70 miles an hour. And since it's working, it's pulling all these other cars right along at the same speed. Okay, it's going right on along. It don't have any problem. The rest of them can't slow down because the SA node is in charge and it's working. So they all have to follow that speed. Okay, say here then that the SA node for some reason derails. That car derails. The first car there derails for some reason or another. Then what's going to happen, again, like I showed you in the other picture, is the AV node, that car is going to have to take over. Well, in this analogy, that car drives or has a rate of 50 miles per hour. So what it's going to do is it's going to pull all of these other cars at that rate, at 50 miles per hour. So it's going to take over the entire train to pull it. So they all continue at that. I'm sorry, I got a little hoarse there. So they're all going to continue at that pace at 50 miles an hour. So that's going to happen. Then say we have here where the AV node messes up. That train, say the second car in the train derails, okay? You still have your first one up here and you got these down here. But what's going to happen is, since the AV node is derailed, it's blocked, then the first part of the train is going to go 70 miles an hour. But the last part of the train is not going to go, because the Purkinje fibers are going to pick that up, and they can only do 30 miles an hour. So what's going to happen is the atria is going to beat 70 beats a minute, but the bottom part, the ventricles, are not. They're only going to do 30 beats per minute. So, but the Purkinje fibers will assume the role of, the autorhythmic cell will take up and pull the rest of it, but it's going to be at a much slower pace. And then something called etopic focus. This is where your Purkinje fibers, for some reason or another, they act up. They start beating really fast. They go faster, actually, than what your SA node does. And when that happens, you have what's called an etopic focus. So what that does is it initiates a premature action potential. So that they're usually called a premature ventricular contraction. So if this etopic focus continues to discharge at more of a rapid rate than what your SA node is, then um, the SA node, the heart rate abruptly becomes greatly accelerated. You get a really fast heart rate. This is due to, it can happen for, like, if you are like asleep, anxiety, drinking lots and lots of caffeine, like lots of those energy drinks. Energy drinks. That's why they say energy drinks are bad for the heart. If you drink a lot of those energy drinks, it can cause what's called an etopic focus, and then just totally mess things up. And it will stay in that way until the heart corrects itself and goes back to normal. But the rest of these issues here will have to have pacemakers put in. You'll have to have some kind of artificial pacemaker installed in to fix, to beat. And what that will do is they'll implant that in the chest, your chest area, and then it will send the signal to your heart to beat. But it won't be like its own conduction system. Your own conduction system at that point is messed up, and you'll have to have artificial means to do that. Well, that's all I've got today. Thank y'all. I'll see y'all next time. Bye.